inertia of the body, unless an external force, the body which is at rest continues to be in its state of rest, or if it is in a constant motion with uniform motion, then it will be in the state of its uniform motion unless an external force is applied on that one. Okay. So similarly, the second law has talked about the acceleration. Okay. So the force applied is proportional to what rate of change of momentum. If net force is 0, there is no acceleration, means there is no moment of the body. Or in other words, if acceleration is 0, net force applying on that body is 0. And we have discussed about many applications of the second law of finding the acceleration and forces when different situations are given. So few more problems will go when we go to the numerical session. But before that, so today we will go with the very important again, and you are very much familiar with that, and that is what Newton's third law. Okay. So let us see what are the important things are there already which you have studied about the Newton's third law, but what new things we can study over here. Okay. So Newton's third law. Newton's third law of motion. Okay. So how this arises? If there is a body, so and this body is moving, if it is having acceleration, means some external force is applied on that. From where this external force is coming? From where this external force is coming? Probably it is coming from another body. Probably it is coming from another body. That means force to exist, that the bodies are required. To feel the force also a body is required. To apply the force also another body is required. Okay, that is what Newton suggested in his Newtonian mechanics books. Suppose there is a spring. Suppose there is a spring. If you compress it, if you compress the spring with the help of your hands, so what will happen? You have applied some force on the spring, and because of compressed spring, you will also get some upward force or some outward force. Okay, so a force applied on you getting some reaction from the spring. So the forces exist because of these two bodies. Okay, so suppose this is the surface of Earth. Suppose this is the surface of Earth. So there is a body. So Earth will exert some force. Earth will exert some force. So that is what gravitational force of attraction. Now will this body exert any force on the surface of Earth? So obviously, according to Newton, this will also exert some force, because force always exists in pair. That is what the Newton suggested. Then we can see the ball moving in downward direction, but we can't see Earth moving. What reason he will give is because of its huge mass. We can't see its motion, or we can't see its effect of the force applied by the small object on the very big Earth. But what he suggested, always in nature force exists in pair. The force does not occur singly in nature. What he concluded, force never occurs singly. Never occurs singly in nature. Okay. So what is suggested? The force never occurs singly in nature. Then how it will occur? Force always occurs, or force always occurs in pair. Okay. So in pair. That means always it occurs with the two forces. Okay, so and what he concluded, these forces are equal and opposite, or forces because of two bodies, or the forces in this pair, these pair of forces always equal and opposite. These pair of forces are always equal and opposite. Okay. So with the help of these three conclusions which he got from these three examples, he has given one statement. What statement he has given? To every action, there is there is an equal and opposite reaction. Equal and opposite reaction. Okay, so this is what he suggested, that Newton's third law. Okay, so this is the statement which he has written in his book Newtonian Mechanics. But if you take this statement, this is absolutely, it's a right statement, but we can people usually what misunderstood this statement. For every action there is a reaction, means they can take anything. They can take anything. They can take some moment of force. They expect some reaction for that moment also. If you slap somebody, you will expect somebody to slap you. That is not a what for every action reaction. Usually, when it used in the literature or something, the people think that for every action and reaction, if you do something, some karma will back you like that. That is not the action reaction pair. What Newton suggested, he did not told anything of some philosophy or spirituality. If you do something, tomorrow it will come back. It is not like that. So it's what he is purely talking about. He is purely talking about force. That is what we keep in our mind. Suppose there is a one body and there is another body. This is what A and this is what B. If the force applied on B by A, force applied on B by A should be equal and opposite force applied by B on A. Force applied on A by B, or you can say force applied by B on A. Okay, so these two forces always exist in nature. Okay, so you can use the symbols like force applied by A on B and force applied by B on A. Okay, so these two forces are equal and opposite. He is telling. That is what the meaning of equal and opposite action reaction here is. Action reaction is nothing but force, not something else. Okay, so that is why what we can modify this law is force always exists in pair. Force always exists in pair. So force acting on A by B, force acting, or for simplicity, force on a body B by A is equal and opposite to force on A by B. That is what the meaning of the second one. That is what action reaction pair means. Here action is also force, reaction is also force. Action is also force, reaction is also force. It is not something else. Okay, so that is why what we can write is the force, that is force by A on B, is equals to force by B on A, but opposite means you have to take the negative. This is what the third law. So force always exists in pair. Force on a body B by A is equal and opposite to force on A by B. Okay, or simply you can say to every action there is a equal and opposite reaction. Okay, so like this, like how we can thinking that action reaction like anything. So there is one more conclusion, that the action will come first, then reaction will come. So this is what the wrong conception usually people used to take when they read action reaction page. It is not like that. So it doesn't mean that first action will come, then reaction will come. It is absolutely wrong. So action reaction exist in this at the same instant of time. There is no time interval between action and reaction. as soon as the body A exert force on B, so at the same instant of time B exert force on A. Okay, it doesn't mean that first action will go, then reaction will come. First earth will attract to something, then something will move the earth. No, it is not like that. So they exist at the same time. Okay, so we are what we can say, action reaction always occurs at same instant of time, at same instant. Okay, so there is no time gap between action and reaction. They are taking place at a time. They are taking place at a time. So that is what they always occurs. What they always occurs at the same instant of time. That is what it is very important to remember. So then there is one more misconception that, so what they will think. Suppose there is a body. So someone will act, somebody will act some force on this one, and reaction will also be on the same body. It is not like that. Okay. So reactions are not taking place on the same body. Suppose there is a surface of Earth. So what will happen? What is this? There is a this body will exert some force. That is what M into G. And the same amount of force will be applied by the surface on the body. That is what normal reaction, which we have already discussed. Okay, these two are not action reaction phase, okay. So why? Because this mg is also acting on the same body, and this reaction is also acting on the same body. But according to Newton, action reaction should act on these two different bodies. Okay, so they will not act on the same body. So this is not an example for third law. If you can take another body here and a surface of Earth here, this may be an action reaction phase. Earth will act some force on body, and body will act some force on the Earth at the same instant of time. So these two are not action reaction phase because they are acting on the same body. So same body will not be applicable. So what statement I can give is these action reaction phase, action reaction forces are on different bodies, okay, not on the same bodies. Okay, so if reaction is on one body, reaction is on one body, reaction should be on another body. If suppose if you take a very popular example of firing a bullet from a gun, so action will be on what? Action will be on bullet. So reaction will be on what? Reaction will be on what? Gun. So they are two different bodies. So that is why they always exist on the, or they always occurs on the two different bodies. That is why they will get cancelled. Okay. So one more important thing is when you take a system of particles, if there are many number of particles, so there is always action reaction forces exist, and they will cancel each other. So that is why as a whole, when you take a whole system, so net force inside the system is going to be what? It is going to be 0. So now we can give the reason of your second law here. When you apply some force, you will take only external force on the system. What about internal forces? Internal forces are cancelling each other because of what? They exist in phase. So this statement will clear your second law also. In second law, what we take? When you apply the force on a body, you will take only external force. What about internal forces? So many internal forces are there. We are not considering internal forces because they are cancelling each other, because internal forces are existing in pair and equal and opposite. So they cancel each other. So net force will become what? Net force inside the system will become 0. Now if you apply any force on the system, only this force is going to be considered, not internal forces, because they are cancelling according to third law, because these internal forces are existing in equal and opposite. Remember, very very important thing. So these kind of conceptual things you should be very much clear. Okay. So with all whatever we have discussed, we can conclude few things. Which are the examples we can consider for the Newton's third law? So to apply to apply Newton's third law. Newton's third law. So what are the things we have to follow? The first point is the forces should act on two different bodies. This is very, very important. Okay, forces should act on two different bodies. Okay, two different bodies, not on the same body. Two different bodies. This is what the first statement. Second is forces should be equal and opposite. Equal and opposite. Okay. So one more very, very important. The forces should be of same nature. Forces should be of same nature. This is also very, very important. If one is electrostatic force, if another is magnetic force, then you can't say they are the equal and opposite forces. If one is electrostatic, another should be electrostatic. If one is gravitational, another should be also gravitational. Okay. For given example, whenever if we take an example, if you look at the example, if these three are holding there, then only we can say that that is the example for Newton's third. Okay. Suppose if I take your just before what we have discussed, this is the surface. So if I put one body over here, so here two forces are there. What is that? One is downward force, that is what mg, another is upward force, that is what the normal reaction. Okay. If you look at the first condition, forces should be act on two different bodies. This first statement only it will not hold here, because this mg or gravitational force is acting on what? Acting on body A. Okay. So this normal is also acting on this body A only. Okay. So they are not acting on these are not acting on two different bodies, or it's not acting on two different bodies. Okay. So mg and n are acting on same body, that is what? On same body, that is E. So that is why this is not an example, but we'll check for some other also. If I look at the second, forces should be equal and opposite, that is so correct. So mg and n are equal. This we have seen in our last discussion. They are equal and opposite also. Okay. So second statement will hold good. First statement will not hold good. We will look at third. Forces should be of same nature. Gravitational force is what? Gravitational force is what? It is a non-contact force. It's a non-contact force. Gravitational force is non-contact force. Okay. Then what about this normal reaction? Normal reaction will come only when there is a contact. Normal force is what? It is a contact force. One is non-contact, another is contact. That means they are not of the same nature. They are different nature. Okay. They are of different nature. So that is why this is also not holding. Out of three conditions, two conditions are not holding here. That means this is not going to be example for our Newton's third law. Then you may ask me, if two are holding, if suppose here two are not holding, one is holding, then you may ask, if two are holding, if one is not holding, then can we take this example? Then also you can't take. If you want to take any example for Newton's third law, these three should be holds for that particular example. If all three conditions are holding, then you can take that as an example. If even a single is not holding, you are not supposed to take that as an example for Newton's third law. So whenever examples comes, you have to apply these three conditions. If these three conditions holds, then only you can take that as an example. If even a single is not holding, that is not going to be an example. Okay. So if I consider for the gravitational force, so this is what the equal and opposite forces. So first condition is what? forces should act on two different bodies. That's okay. It's the body A and this is the Earth. So obviously acting on what? Acting on two different bodies. Okay. So first one is what's good. Second, equal and opposite. Obviously they are equal and opposite forces. Okay. So if you look at third one, this is also gravitational force. This is also attracting because of gravitational force. Means both are acting because of what? Non-contact forces. So forces are of same nature. Forces are of same nature. Okay. So that is why this is going to be example, because all three are holding what? All three are holding good. Okay. So that is why what we can take this, the force between a body and Earth gravitational force, as an example for Newton's third law. Okay. So like that, many examples are there. We can see that. So we'll see the examples. Okay. So the very popular example, that is what? Firing of bullet from your gun. Okay. So if you fire a bullet, so bullet is moving because of what? Because of action, and this is moving backward because of what? Because of reaction. You can check. These two are equal and opposite because this is moving in this direction, it is moving in this direction. Obviously they are equal. And if you look at the second condition, first condition, they are acting on two different bodies. Bullet is different, gun is different. Okay. So then if you look at it, whether they are same nature or not, they are same nature because both are contact force. That will push the bullet on forward action and bullet will push the gun on backward action. So this is going to be an example. What is that? Firing of bullet from gun. Obviously you have to fire from gun only, but we have to write. Okay. So if you look at the second example, that is what? Suppose there is a, you can say, suppose there is a person swimming. Okay. So this is what the water. Okay. So if you want to move forward, so what will happen? He will push this water in backward direction. That is what the force is applying on the water. And because he is pushing the water backward and he is coming in what? Forward direction. Okay. That is the man moving in forward direction. He is pushing water in backward direction. Okay. So force, action will be on water, reaction will be on the person. Okay. So action is on water, but reaction is on what? Reaction is on man. That means they are acting on two different bodies. Action is acting on water and reaction is acting on the man. Okay. So second condition is what? Second condition is they should be equal and opposite. Obviously, how much force you will apply, that much only that will push you. And third is they should be of same nature. So both are contact force. When you touch the water, then only you can move. It's contact force. So since you are in touch with water, then only it can push you. So that is also contact force. So swimming of person is also what is also a example of for the Newton's third law, swimming of man. Okay, obviously you can take an example, not only man. So similarly, walking of person. If you look at the walking of the person, so what will happen? So okay, you can take this as walking. So when you are when you start walking, what you do? You will not make your body to move forward. Instead of that one, you will apply the force on the ground. This is what the ground. You are applying force on the ground in this direction. Okay? You are applying the force F. Since you are applying force in backward direction, you can observe you are working properly. You are not applying force in forward direction. If you try to apply force in forward direction, you will slip down. You will always apply force in backward direction. You will press the ground. When you press the ground, that is what? Action. So this earth will give some reaction. Earth will give some reaction. This you can take it as R. This is what the F. Okay. So then if you are applying force on the earth, obviously earth is moving in this direction, but you can't observe because very big size. Okay, and the effect will be very small because of the size. Because of reaction you are moving, not because of your action. Remember, you are walking because of reaction of the earth, not because of the what your force. Okay. Now this force you can divide into two. Okay. This is going to be a normal and this is going to be a horizontal. Okay. So this I will take as a horizontal component H. This I will take it as a vertical component. Okay. So what is this H is? You can take if this is the theta. Okay. So what you can say r cos theta. So similarly this is going to be what r sin theta. So you are not moving upward. You are not moving upward while walking because that will balance by your weight mg. That will be balanced by your weight mg. So upward reaction and downward your weight will be what will be balanced. So you will not move in upward direction because of reaction of the earth. But you will move forward because there is no backward force. So because of its reaction component along the horizontal direction, you can walk. Okay. So that is what it's very important to understand working of a person. Okay. So you are working because of what? Because of horizontal component earth reaction. Okay. So this is also working of a man is also a best example for your action reaction phase. Okay. So remember, walking is a process due to the reaction of earth, not because of your action. Okay. So this we will study properly again. And if you look at the motion of the vehicle, okay, suppose you are having the car, okay, think that you are sitting over here. So now this is what you are wheel. So usually engine will be for the your back wheel, not for the front wheel. So what will happen here? So usually your wheels will rotate in this direction. Yes or no? If wheels are rotating in that direction, obviously you should move in backward, but you will not move backward. Okay. So when wheel will move in this direction, so some frictional force will act in this direction. Reaction will be in this direction. This is what the action, that is the force applied by the wheel. Force is applied by the wheel is in backward direction. It is not in forward direction. Wheel are rotating like this, not in reverse. Okay. So if wheel run in this direction, that is what the action. So that earth will give what? Reaction. Because of that reaction, your vehicle is moving, not because of the engine. Because of engine, your vehicle is not moving. Because of reaction of earth, your vehicle is moving. That is what the best example for your action reaction phase. Okay. So remember, these are the what examples which we can see in our day-to-day life.